Welcome to RCE. Today I would like to discuss about numerical integration. So we know that integration from a to b f of x dx represents the area between y equal to f of x, x-axis, and the ordinates x equal to a and x is equal to b. So we can evaluate this integration only if the function is given clearly and if it is integrable. So here we can replace the function f of x by an interpolating polynomial Pn of x and obtain integration of Pn of x dx, which is almost equal to the integration from a to b f of x dx or integration from x0 to xn f of x dx. In numerical integration there are three methods. One is trapezoidal rule, second one Simpsons 1/3 rule, third one Simpsons 3/8 rule. So in a trapezoidal rule, the formula is integration from x0 to xn f of x dx is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus y3 plus so on plus yn minus 1. That is h by 2 into y0 plus yn means the first ordinate and the last ordinate, their sum, plus 2 into the intermediate ordinates. That means all the y values that are in between y0 and yn. So here h is the step length. So this method is simple for calculation purposes. So but there is some error associated with this method. So we can increase the accuracy by increasing the number of intervals. That is nothing but decreasing the value of h. Coming to the second model, Simpsons 1/3 rule. Here, if n is an even integer, integration from x0 to xn f of x dx is given by h by 3 into y0 plus yn, that is the sum of the first and last ordinates, plus 2 into the sum of the even ordinates, plus 4 into sum of the odd ordinates. That is h by 3 into y0 plus yn plus 2 into y2 plus y4 plus so on plus 4 into y1 plus y3 plus so on. So this is nothing but h by 3 into sum of the first and last ordinates plus 2 into sum of the remaining even ordinates plus 4 into sum of the odd ordinates. So coming to Simpsons 3/8 rule, if n is a multiple of 3, so then integration from x0 to xn f of x dx is 3h by 8 into y0 plus yn plus 3 into y1 plus y2 plus y4 plus y5 plus so on plus yn minus 1 plus 2 into y3 plus y6 plus y9 plus up to so on yn. So here the above equation is called Simpsons 3/8 rule. So which is applicable only when n is a multiple of 3. So to apply Simpsons 3/8 rule, normally we will take n as a multiple of 3. So now we will take up one problem where we are going to evaluate integration from minus 3 to plus 3 x power 4 dx by using trapezoidal rule, second one Simpsons rule, and verify the results by actual integration. So first of all, here the function is y of x is x power 4. So the length of the interval is upper limit minus lower limit, that is 3 minus of minus 3, that is 6. So we are going to apply both the trapezoidal rule and the Simpsons rule. So that's why we divide the total interval into even number of subintervals, right? So that means we will take h as upper limit minus lower limit whole divided by 6. That denominator 6 is n, number of subintervals. So h is equal to 6 by 6, that is 1. So with the help of this h is equal to 1, we formulate a table where the x values begin with minus 3 and end with plus 3 because they are the lower and upper limits. So the starting value for x is minus 3, and then you add 1 to that minus 3, you will get minus 2, then minus 1, then 0, 1, 2, and finally 3. Now you put all these x values in the given function x power 4, then you will get the y values. They are nothing but the functional values. Now first we will use trapezoidal rule. So the formula is integration from minus 3 to plus 3 y dx is equal to h by 2 into sum of the first and last ordinates plus 2 into sum of the remaining ordinates. So that is h is 1, so that's why it is 1 by 2 into 81 plus 81 plus 2 into sum of the remaining ordinates. Then we are getting the answer as 115. Now by Simpsons 1/3 rule, here we have taken n as even number. So since n is even means number of subintervals is even, automatically the number of ordinates will be odd. The y values in the table, they are odd. So now integration from minus 3 to 3 y dx is equal to 1 by 3 into same, you apply Simpsons 1/3 rule and you substitute the respective values from the above table, then you will get 98. Since n is 6, is a multiple of 3, so that's why we can apply Simpsons 3 by 8 rule. So by this rule, integration from minus 3 to 3 y dx is equal to 3 by 8, because h is already 1, so 3 by 8 into first value, last value, sum of the first and last ordinates. So 81 plus 81 plus 3 into, right, the remaining ordinates plus 2 into the respective values, right. So the total answer is 99. Now we are going to compare these results with our actual integration. So the actual integration is integration from minus 3 to 3 x power 4 dx is, since the function x power 4 is an even function, I can write it as 2 into 0 to 3 integration x power 4 dx. So then obviously it is 2 into integration of x power 4 is x power 5 by 5. The lower limit is 0, upper limit is plus 3. We are using the even function concept. So now by substituting the upper limit and lower limits, we will get the answer as 97.2. So if you compare this result with our previous 3 values, we can observe that only Simpsons rule, it gives a better result when compared with trapezoidal rule. So the problems for the practice purpose. Thank you.